Hello, geometry students. Mr. Zacek with you here, back and better than ever. Moving through Unit 5, we're in Lesson 4. Today we're going to talk about the centroid and the orthocenter. And these are points of concurrency that happen in a triangle. So today we're going to look at the median first, just as a review. The median of a triangle is a segment whose endpoints are a vertex and the midpoint of the opposite side. And we can recognize a median with a few different ways. So one way is the vocabulary. They tell us the word median. Okay. Another way would be tick marks that indicate that this is the midpoint, which we have in the picture, or another way would be through measurements. And so the medians are concurrent at the centroid, and the centroid is this point. It's the point of intersection of the medians, and the centroid is also called the center of gravity of a triangle because it's, if you were to balance the triangle, that would be the balance point. So when my little device for remembering this, that the medians are connected with the centroid, is both of these have, I think, 2E. So the medians and the centroid, the second letter is E. That's just a little tool that I have that goes with a song that I'll share in another video, but we've got it there. So the centroid, center of gravity. So let's go ahead and construct this now. Now again, a median is where the goes from a vertex to a centroid. So I start off and I kind of do it a little bit like I'm going to do a perpendicular bisector, because bisector will get me to the midpoint. So come over here. I'm not going to draw the whole surfboard this time. I'll just do that, and then with your straight edge tool you will come down, and the point of this is to get ourselves the midpoint. And now the median is drawn from a vertex to the midpoint. So there's our median. So let's go ahead and do a second median. I'm going to do side BC. Again, we could do all three, but we don't have to do all three. Okay, so above, below the line, same compass setting. And we get here, so there, and oh, did I draw enough the other one? Just enough to get that one. So now with your compass, we draw this, which gives us the midpoint. And again, the median is drawn from a vertex to the midpoint of the opposite side. So we have those there. So I'm going to just add a couple, first of all, let me move this out of the way. I'm going to add a few letters here. I'm going to call this point D down here and point E. So the two medians that I've drawn here are BD and AE. All right. So the intersection point here is the centroid. All right, so that point right there, there is our centroid. So we'll do a few more of these, and you can go ahead and construct these. I'm not going to do it all right now, but go ahead and do the constructions for both of these. Here's what we're going to notice from doing the constructions for all of those. All right, think about this. The centroid is the balance point where you have to stick it on it. So can the centroid ever be outside of the triangle? No, otherwise it won't balance. So it will always be located inside the triangle. Okay, always be located inside the triangle. Now I will do one more so I can answer this question 5 here. I'll do the obtuse one down here. So let's go ahead and open this up. All right, here we go. Got to get more than halfway, so I can do above and below, or both sides, above and below. And if you were, doing this, you don't necessarily have to draw the whole perpendicular bisector. If you use your straight edge, really all we need is the midpoint, so we can get the median. And what do we say? Let's do this one over here as our next one. Okay, come down. Okay, notice that's the same arc that we have there. Didn't want to move that. All right, so we bring a compass over here above, come down here below. All right, and use a straight edge, and that's going to give us the other. All of that gets us this midpoint right here. So once we have the midpoint, we can draw the median. Okay, and so then now 2 of them, and it would be all 3, intersect at intersect here. So this point right here is again, that's our centroid. Well, so the question is, using a compass, compare the 2 lengths the centroid divides the median into. So here's what I want you to see. If I take this compass here and I measure this length, so I'm going to measure from the midpoint up to the centroid, and then we come up here, and then we come up here. Look at that. Hey, we have an interesting relationship. Okay, so here's what we notice. The distance from the vertex to the centroid, okay, equals 2 times the distance from the centroid to the midpoint. So it's double the length, and that's a key relationship. This is one of those in this topic, it's one of those questions that gets asked a lot. So the centroid divides a median into the ratio of 2 to 1. The longer segment extends from a vertex to the centroid, and the shorter segment extends from the centroid to the midpoint. All right. So now we're going to do some examples that deal with that length. So in this triangle over here, triangle XYZ, XA is 8. So let me get a little highlighter here to show you. Okay, so XA, that length is 8. What I want to notice about XA is XA is from a vertex to the centroid. Now I should pause for a moment and just say, how do we recognize the centroid? So we want to recognize centroid not just because we're doing this part of the lesson and we've been talking about centroid, but we want to recognize it from the tick marks which show midpoints. And therefore medians. Okay, so here's the relationship. XA equals twice the length of AB. So XA, which is 8, equals 2 times AB. So if we divide by 2, 4 equals the length of AB. So I've got a length here of 8 and I got a length here of 4. What is the length of XB? Well, XB equals XA plus AB. So XB equals 8 plus 4. XB equals 12. All right, so walking you through that process. Now, question part B here. ZA is 9. Okay, so that's ZA over here. I'll use a little different highlighter color. ZA is 9. What is the length of ZC? Okay, so again, we've already established that this is the midpoint. Well, ZA equals twice AC. So again, ZA is 9, twice AC, divide by 2. So 4.5 would be AC. That's this little piece right here. So now what is ZC? Well, ZC equals ZA plus AC. So ZC is 9 plus 4.5, which would be 13.5. So what is the ratio of ZA to ZC? Well, ZA is the longer side and AC is a shorter side, so it is 2 to 1. All right, and because well, if we take 9 and we divide it by 4.5, if you just take the lengths, that equals 2 over 1. And we just know the relationship, okay? We know this relationship exists with a centroid. So again, this is one of the most commonly asked type of questions related to these questions is about the length. And so for the first part of this chapter, this one gets asked a lot. All right, triangle ABC has vertices 0, 1. Okay, so there's A. B is 3, 6. That would be up here. And C, it would be 6, 1. So we draw here, here, and here. Now, we want to find the coordinates of the centroid. Okay, so again, centroid, here's the thinking we have to have is the intersection or the point of concurrency of the medians. And when we think about medians, we want to think about midpoints, right? M and M. That's what I think about with medians, M and M. So we need to find the midpoint of the sides that we have here. So let's pick a couple sides. Maybe let's start with AB. So A is 0, 1, and B is 3, 6. So the midpoint of AB, what's our midpoint formula? X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. The midpoint formula, that's for you. You have to add and divide by 2. So again, the midpoint of AB would be 3 halves and 7 halves. That's like 1.5 and 3.5. So that would be right here. Well, that would allow us to draw the median, which would be this line segment right here. And maybe next I'll do BC. So what would the midpoint of BC be? Well, B is 3, 6 and C is 6, 1. Let's do the midpoint. So the midpoint of BC would be 3 plus 6 divided by 2, 6 plus 1 divided by 2, okay, which would be 4.5 and 3.5. So 4.5 and 3.5. Okay, there it is, kind of lined up right across from that other one. All right, let's draw that out. And now we have those two lines right there. Now you see how kind of thick they are? I'm going to do the next kind of midpoint just by accounting. See how we go down 1 over 6? That would mean the midpoint of this one would be right there on that line. So now that one comes down. All right. Now they all need to intersect. And so, you know, I've got a really thick line here, which is kind of throwing this off. But really they're going to intersect right here in that point. So the centroid would be the point 3, 2.5. Okay, so we do that, and again, have a sharpened pencil. That'll help just to get that be more accurate for you. All right, okay, so let's look here now. For triangle PQS, this is going to be like some questions that you'll see on upcoming quiz. Is PR a median, an altitude, or neither? Explain. Okay, well, PR, it goes from a vertex perpendicular to the opposite side, so that is an altitude. Okay, because it goes from a vertex perpendicular to the opposite side. All right, in this same triangle, is QT a median, altitude, or neither? Well, that's a median because the tick marks indicate that T is a midpoint. And a median goes from a vertex to the midpoint. So from a vertex to the midpoint of the opposite side. All right. So for triangle ABC, is each segment a median, altitude, or neither? All right, let's look. AD. See how AD, A is a vertex, D is a midpoint. That means that is a median. EG. Okay. Well, we've got E as a midpoint. We don't know that G is a midpoint. Okay. Can't determine what G is. So we don't know what that is. It's neither of those two. All right. It might be a mid-segment, but we don't know, and that's also not one of the options. CF goes from an altitude perpendicular to the opposite side, I mean from a vertex, so that was called an altitude. All right, now, did I miss something here? Okay, just got to cover this next little bit. All right, what are the coordinates of the orthocenter of triangle ABC? Okay, well, an orthocenter is the intersection of the altitudes, or is the point of concurrency of the altitudes. So now I can finish one of the songs that I did in an earlier lesson. In a triangle you have 3 lines, and you need to know where they come together. It's the point where they meet. Okay, sorry to stop there, but my program closed, and it's in the middle of the song, and I'm not going to write all that out again, but here's where what I will write is that whoops, don't do that. The altitudes, okay, meet at the orthocenter. So in a triangle you have 3 lines, and you need to know where they come together. It's the point where they meet, called concurrency, where the 3 lines come together. Orthocenter, it's the intersection of the altitudes. Altitudes. Orthocenter, it's the intersection of the altitudes. Altitudes. In a triangle you have three lines, and you need to know where they come together. It's the point where they meet, called concurrency, where the three lines come together. Orthocenter, it's the intersection of the altitudes. Altitudes. Okay, enough of that. All right, now, what are the coordinates of the orthocenter? All right, so here's what we got to think about with an altitude. All right, so an altitude is vertex perpendicular to the opposite side. Okay, so if we look at this, I'm going to do AC first because that's a horizontal line. And so let me just do a different color here. The altitude to a horizontal line out of B is going to be a vertical line right there. Okay, that's kind of the easy one with when you have those two. Now, in order to get the other one, I need to do a little bit more work. So I'm going to start off by finding the slope of BC. Okay, well, BC, I'm going to call this my x1, y1, x2, y2. I'm kind of breaking a little rule here by not bringing it down into the place, but y2 minus y1 over x2 minus x1, right? y2 minus y1 over x2 minus x1. So I get negative 4 over 4, which means that the slope of BC is going to be negative 1. Now, an altitude is drawn perpendicular. So that means that a perpendicular slope is going to be positive 1. So we want to think these two are negative reciprocals. Well, when you flip 1, you get 1. So it doesn't, in that case, all we're doing is changing the side. So what we do is we come over here, and now I'm going to use rise over run. I know it's got to come out of point A, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, this segment right here, let's put it as a different color, from the vertex to the perpendicular to the opposite side is the altitude. Okay, so we just created another altitude. Where do they intersect? So the orthocenter is the intersection of the altitudes, which is the point 2, 3 in this case. All right, so we're putting a bunch of things together here, kind of assuming some prior knowledge with these things that we worked on related to the orthocenter and the centroid. So the two things here, medians meet at the centroid, and we want to think about they're in a ratio of 2 to 1. And the altitudes meet at the orthocenter, and we want to think altitudes come from a vertex perpendicular to the opposite side. Okay, so from here we got a few assignments and getting ready for a quiz on the first half of this. So good luck with that. Let's keep on asking questions.